In this video, we're going to keep talking about the differences between solids, liquids, and gases. In my last video, I was explaining how a solid can be thought of as, these atoms or molecules attached by a bunch of springs. And in a solid, there's a specific way that they're lined up, and they're all connected in a certain way. And this is a very simple way that they could be connected. And this is called their crystal structure. Oops. Their crystalline structure. And it makes them particularly stable. And it also makes them rigid and have a pretty much constant volume. And let's talk about these. So the structure makes them particularly stable now because if you imagine me pulling this molecule out, if I wanted to move it, right, I would now be stretching out 3 springs. And the springs would say, no, come back. And there would be this force to kind of keep it together with the rest of them. And that's a little more stable than when we were thinking about maybe just 2 molecules doing that to each other. And we'll talk about the differences between this and a liquid. But this specific structure makes them particularly stable, which means that these have a really highly negative, so very negative potential energy. This structure also makes them rigid, right? If this is kind of how they're arranged by nature, they're not going to flow by each other, right? This kind of molecule 1 will always be above molecule 2 and adjacent to molecules 3 and 4, etc., right? And this is kind of why solids kind of keep their shape. In terms of constant volume, we see that if we tried to press all of these guys together, right? If we tried to press these together, we would be compressing the springs. And that would create a net repulsive force, and it would kind of resist us changing its volume. The same with stretching it out. And that's why solids can't really be compressed. In the last video I was talking to you about an analogy if solids are kind of like balls attached by springs, liquids don't actually have that specific structure. So liquids lack that crystalline structure. But they're about equilibrium distance apart still. So they still get to benefit from the kind of stabilizing forces, right? But instead of having a set structure, you can think about, well, what if they weren't kind of all connected to each other in a specific way and they could all kind of float around? And this is where the analogy gets kind of weird. So if I have my molecule now and it's kind of just attached to springs like this, but they're not really attached in a specific way and they can all kind of move around, it is easy to see why they couldn't get too close together, right? If they got too close together, the springs would compress and they push each other away. The thing about this drawing and this kind of analogy that doesn't really work is that they also attract each other, right? So if they get too far apart, they actually come together. And that's why the analogy is kind of weird. So another way to look at this is just as kind of the molecules. And just remembering, and I'll draw dotted lines, that they're all attracting each other. But they're not like in a set structure or anything, right? They're kind of attracting each other, so none of them are going to wander off. But they won't get too close because then they'll start to repel. And this is partly why liquids can flow. And that's because now that these molecules aren't locked down in specific positions with respect to one another, now molecule 1, well, maybe it's going to end up over here, and that's fine, right? And then the other molecules would kind of attract it and make sure it doesn't wander off too far or get too close to anybody, right? Because of that balance between attractive and repulsive forces. So liquids can flow. For the same reasons as solids, they can't really be compressed. They have a constant volume. And again, if we get them too close together, you're going to get that repulsive force pushing them back away. And again, just by the fact that the distances here are close to the equilibrium distances, they are stable in a way. They're kind of, they're not allowed to do exactly what they want, right? So the molecules, liquids still have a negative potential energy. And that's just reflecting their distance from each other.